Fine. So the bottom line is, if you have taken 1 degree amine and you made that 1 degree amine to react with either sodium nitrite with HCl or nitrous acid, that 1 degree amine is going to convert into a alcohol like this. Fine. Now if you take 2 degree amine and if you carry out the same reaction, you take sodium nitrite along with HCl or you take nitrous acid, then we understood that this reagent basically generates nitrosonium ion. Fine. So what happens is, this nitrosonium ion will again come to this amine as it came to 1 degree amine. So the first step of the reaction will be the same, exactly the same as it happened for 1 degree amine. The first step, nitrogen formed a bond with this nitrogen. The nitrogen of nitrosonium ion formed a bond with the nitrogen of amine. And this nitrogen has given its electron. So this nitrogen will gain a plus charge that will be dispensed when that hydrogen is released. That's what happened in 1 degree amine. In 1 degree amine, we were in the exact same position like this. But the problem was, but the advantage or the condition was that this nitrogen had 1 more hydrogen in case of 1 degree. In case of 2 degree, there is no more hydrogen. So what happens? The reaction further proceeded in case of 1 degree amine. Because if you remember, when this happened, when this nitrogen gave its electron for the second double bond, then the plus charge appeared on this nitrogen and that was removed when this hydrogen came out. The similar thing if happens in this case, then the plus charge will appear and this nitrogen do not have a mechanism to get rid of that plus charge. So the similar thing will not happen in this case. So the next all the other steps will not happen in this case. So the reaction will stop in this case. So what is the final product if the reaction is 2 degree amine is nitrosoamine. This will be the final product. If you take 3 degree amine, if you take the same reagent, then this same reagent is going to form the same reacting species once again, that is nitrosonium ion. And if you go for the reaction similar to that we had before, then this is what is going to be formed. This nitrogen is going to gain a plus charge. That plus charge cannot be dispensed off because there is no hydrogen. Turns out that plus charge cannot appear on nitrogen because there is no mechanism to dispense that plus charge. And this plus charge cannot remain on this nitrogen like this. So turns out that there will be no reaction in this case. So in case of 3 degree, there will be no reaction. In case of 2 degree, you will have nitrosoamine. In case of 1 degree, you are going to get alcohol. Alright. So time to solve a conversion problem. Let's start with a simpler one first. Suppose I have propenoic acid. Suppose first I add hydrazoic acid. Remember hydrazoic acid? In which reaction did we study this hydrazoic acid? HN3. By the time I complete this conversion, you should be able to remember which reaction had this reagent, hydrazoic acid. On A, I'm adding HNO2, I'm getting B. Okay. Then suppose just to remind you, just to help you remember the reactions and just for a quick revision of a reaction of a chapter of carboxylic acid, let me add just this. It's a simple conversion, not involving much of the reactions. These two are the recent reactions we have studied. This is a reaction that we studied in the chapter carboxylic acid, and just let me quickly check if you remember this reaction of the previous chapter. So ABC, 3 molecules, you have to identify. 30 seconds is the time limit that you should set for yourself. Okay. So I assume your 30 seconds is over, although I'm not going to wait for 30 seconds because you have a mechanism to pause the video and wait for 30 seconds and then resume it. So from this propenoic acid, you are getting A. Of course, this reaction is Smith reaction, and that happens in carboxylic acid. When it happens on a carboxylic acid, this carboxyl group goes away in carbon dioxide gas, and an amine group gets added. So no trouble in identifying that A is ethanamine. Now on ethanamine, you're carrying out this reaction of HNO2. This reaction is diazotization reaction, in which primary amine gets converted to alcohol. This is the most recent reaction that we have studied. So your memory, your brain mechanism should serve you well to identify that B is ethanol. Fine. Now if we add LAH is lithium aluminum hydride. If you are adding LAH on this propenoic acid, what happens is that this acid gets reduced to alcohol, and the number of carbon will remain the same. So C will be propanol. Fine. So if someone asks you what's the relation between B and C, what will you answer to him? What's the relation between B and C? B and C have same functional group, and B and C differ in the CH2 unit. And those kind of compounds having same functional group differing by CH2 unit of 14 AMU are called homologues. So your answer should be B and C are homologues. Okay, let's try this one out. We have acetophenone, and I'm carrying out this reaction on acetophenone. It gives me A and it gives me B. B is yellow in color. On A, I'm adding HN3. I'm getting C plus D gas. On C, suppose I add HNO2, I get E. On E, if I add B and KOH, this B is same as the B here. Then I get F. So identify A, B, C, D, E and F. So this reaction is very familiar reaction. We have practiced various conversions incorporating this reaction. You will have no trouble in identifying this reaction. This reaction is haloform reaction, because this yellow thing is haloform. You get a gut feeling because this is acetophenone and you're getting iodine here. So this must have iodine, that is iodoform. You know this. So this is acetophenone, and acetophenone, you know what acetophenone is. If you remove that methyl part and make the acid of the rest of the part, then A would be benzoic acid. I'm going a little fast because I'm assuming you are following the video in order. So we have did the very same reaction various times in various conversions. So I assume that I can go a little fast. So this is benzoic acid, and B is iodoform. You're carrying this reaction on acid. We did the same kind of reaction in the last conversion, and C gives you aniline. This acid group goes away and this NH2 group is added. This is Schmidt reaction. On D, D is a gas, and this gas, you know what this gas is. This is CO2 gas. This acidic group comes out in the form of CO2 gas. So D gas is CO2 gas. Now you have amine, and you're adding HNO2 on this amine. So you know which reaction is this. This is diazotization reaction, the last reaction we have studied, and this E, we'll have no trouble in identifying. This E will be phenol. NH2 group comes out and in the form of N2 gas, and OH group gets added. This is phenol. On phenol, you're adding KOH and iodoform, and you're getting F. The first thing is identify which reaction is this, and then get to the product F. So to identify the reaction, you have to know which reaction is this. This is E is on phenol. So either we studied this reaction in the chapter of phenol, or we studied in this reaction in the chapter of the functional group which is there in F. So we studied this reaction in both the chapters. In phenol you were taught this, and what comes out as product is aldehyde. So in aldehyde also you were taught this. So this reaction is Reimer-Tiemann reaction, and you should have figured it out by now. In Reimer-Tiemann reaction is a well-known reaction and you must be knowing it, so I'll not go in any detail to discuss it. The product is well known, is salicylaldehyde. This is what F is. In case you are having trouble, type down Reimer-Tiemann reaction on YouTube. You'll get that video, listen to that. This is Reimer-Tiemann reaction and the product is salicylaldehyde. Fine, easy.